Hello everyone, today we are going to calculate the Urbach energy. The defect states in an optical bandgap region are represented by an optical parameter known as Urbach energy. These localized defect states in the bandgap region are responsible for formation of absorption tail in the absorption spectra, which is termed as Urbach tail. And the energy associated with this tail is called as Urbach energy. In order to determine the Urbach energy using absorption spectra, we need to plot a graph with log of absorption coefficient alpha versus wave energy of the associated wavelength or energy of the wavelength that we have. So we are for this we have this data, that is wavelength versus absorption. If we plot this, we will get a kind of plot, absorption plot, that we can see here. Now we will calculate the alpha, that is absorption coefficient. Absorption coefficient can be calculated by dividing the absorption by the thickness of the film that we have used. And the thickness of the film that we have used is about 1.5 micrometers. So we will divide absorption, that is column B, divided by 1.5 micrometers. So this is the absorption coefficient alpha, and now we will calculate the energy, that is h nu, and it is given by 1240, that is 1240, divided by the wavelength, that is column A. So here we have energy. Now to calculate the Urbach energy, we need to take the log of alpha or log of absorption coefficient. Here we will set B column as X. So we get this, and now when we plot this, we get a plot like this. Here we have to linear fit the linear portion of this region. For this, we will select the linear portion. This seems to be a linear portion of this plot, and we will fit it using fit linear function. Here we can see the slope of this plot, that is 1.3911, and the inverse of this slope will give us the Urbach energy. So Urbach energy EU equal to 1 divided by slope. And the inverse of this is, that is 1.3918. Its reciprocal is 0.71. So Urbach energy equal to 0.7188. Thank you.